Now we're going to talk about what's called the remainder theorem. So let's look at a simple division problem. Let's say you had 10 divided by, no, let's say you had 13 divided by 5. Well, then you would say, okay, how many times does 5 go into 13? And you'd say 2, and you'd get 10, and you'd subtract. This is long division here, right? And then you'd have a remainder of 3. But if you wanted to check it, if you wanted to get the original number back, you know, the dividend, you would take your quotient 2 times what you divided by, 5, and then you'd have to add in the remainder. That's how you would get the 13. That's the check, okay? So I'm going to try to show that now to you with polynomials. So let's say you have f of x divided by x minus c, some polynomial. But the quotient is going to be, you're going to get a quotient in terms of x plus a remainder, right? Okay, so if you wanted to check it, f of x would equal q of x times x minus c plus, and then you'd have to add in the remainder, okay? Now, that might look a little odd to you the way I have it written. It looks odd to me. But that is true. That's how you do it. You have to add in that remainder, okay? Now, what if x were equal to c? So what if x equaled c? Then you would have f of c. So you want to evaluate the original function at c. Then you could say, well, that's supposed to be a q, not a g. Q of c times c minus c plus r, the remainder. Well, what's c minus c? That's just 0, right? And it doesn't really matter what q of c is, because q of c times 0 is just going to be 0. And so you're going to have 0 plus r, which is just going to equal r. Okay, so follow this down. And here's what it says. If you want to evaluate a function at some number, you can just put in that number and do synthetic division, and whatever you get for the remainder, that's what it's going to equal. Okay? So let me give you an example. I know that probably doesn't make a lot of sense, but I'll show it to you 2 ways. Okay. So let's do it the way that maybe you're thinking of first. Use the remainder theorem to find the remainder when this function is divided by x plus 2. Check with synthetic division. Okay, so it says, I think they kind of take a backward approach. They say f of negative 2 is going to equal, and then they go negative 2 to the 3rd power plus 4 times negative 2 plus 15. Now that should seem normal to you. You're taking a function and you're evaluating it at negative 2. Now, why do you have to use negative 2? Again, it's that x minus c idea. Okay? So I plug that in, and what do I get? Negative 8 minus 8 plus 15. I get negative 1. All right? Now, they say check that and see if it's right. Okay, so now we're going to treat it like a regular synthetic division problem. We're going to put negative 2 up in the box. We're going to pull off our coefficients. Now, x squared is missing, so I'll have to put in a 0x squared. 1, 0, 4, 15. Okay, the 1 comes down. 1 times negative 2. 0 and negative 2 is negative 2. Negative 2 times negative 2 is 4. 4 plus 4 is 8. And then 8 times negative 2 is negative 16. And what did we get for the remainder? Negative 1. So we were right. The remainder was negative 1. Okay. There we go.